OSIRIS REx is a NASA mission to explore a near-Earth asteroid Bennu. Bennu is an asteroid whose orbit crosses the orbit of Earth, as you can see here, making it a threat for us. Studies say that there is a 1 in 2700 or 0.03% chance that it will hit the Earth when it next passes by, which is pretty low but not zero. The asteroid is about 263 meters wide and weighs about 78 billion kilograms. And when you crunch the numbers in, it turns out when it hits the Earth, its energy will be 24 times more powerful than the most powerful nuclear weapon ever made. So we had to know about this asteroid more. In this video, we'll look at how OSIRIS REx began its journey from home, collected samples of Bennu, and returned to Earth safely. On September 8, 2016, OSIRIS REx began its journey from Cape Canaveral, Florida, aboard an Atlas V rocket. Right before sunset, 1 hour later, OSIRIS REx separated from its fairing and upper stage rocket. Then it extended its solar arrays and left the Earth. After a year of orbit around the Sun, OSIRIS REx returned to Earth for a gravity assist, which means that it used the gravity of Earth to match the orbital tilt of Bennu, sending it on a path which will allow the spacecraft to meet up with its target. And while it did that, OSIRIS REx also took pictures of the Earth and the Moon. After 2 years of chasing its target, OSIRIS REx began its approach phase. It captured Bennu's first light as a single dot moving across the field of stars. When it got closer, it revealed its size and shape for the first time. Then OSIRIS REx began its preliminary survey, in which it measured its mass and gravitational acceleration. On New Year's Eve, OSIRIS REx got close enough to be captured into orbit, making Bennu the smallest object ever to be orbited by a spacecraft. Now NASA was trying to find a suitable landing site for sample collection, but the surface of Bennu was so rough that NASA was not able to find it. But then a musician named Brian May helped NASA by giving the idea of stereoscopic imaging. Brian May is not just a musician, he is also an astrophysicist, and his idea actually worked. See, stereoscopic imaging is a 3D imaging process in which the spacecraft observed Bennu at different angles to get a 3D view of it. Then finally, NASA found a 10-meter wide landing site in the Nightingale crater for sample collection. Then OSIRIS REx practiced autonomous flight. First, it passed by the selected landing site to match Bennu's rotation. Next, it practiced to lower within 30 meters to match Bennu's rotation and speed and necessity for safely touching down. Finally, OSIRIS REx was ready to collect the sample. Before touchdown, OSIRIS REx extended its tag SAM, which has the technology for sample collection. In its final descent, it retracted its solar arrays for safety. It descended at speed of centimeters per second. When it had its touchdown, something strange happened. OSIRIS REx tag SAM sank nearly half-meter into Bennu's surface. We expect an asteroid's surface to be hard and rocky, but this was not the case with Bennu. It's like a loosely held body because of its minuscule gravity. That's why OSIRIS REx tag SAM sank into Bennu's surface after touchdown. The tag SAM blew high pressurized nitrogen gas because nitrogen doesn't react with any material, so it won't contaminate the sample. Blowing nitrogen gas stirred up loose materials like rock and dust while letting the gas escape to space. After sample collection, rocks and debris were flying everywhere, so OSIRIS REx fired its thrusters to retreat to a safe distance. Now OSIRIS REx had to determine the mass of the sample, so OSIRIS REx fully extended its tag SAM and performed a spin maneuver to calculate the centrifugal force, measuring the mass of the sample. If at least 60 grams had been collected, which it did, collecting 70 grams of rock and dust, OSIRIS REx will stow the sample into the sample return capsule. Stowcam watched closely as the sample had entered the return capsule, and this is the real footage of it. Then the tag SAM detached from the sample head, then sealed the sample return capsule and prepared its journey back to home. After departing from Bennu on 10 May 2021, OSIRIS REx finally arrived on 24 September 2023, releasing its sample return capsule and deflected away from Earth. The capsule entered the Earth's atmosphere at nearly 12 kilometers a second. For comparison, a typical bullet travels at a speed of only 760 meters per second. The temperature of the heat shield rised up to 2900 degrees Celsius due to the friction of the atmosphere. At an altitude of 33 kilometers, the capsule initiated its parachute sequence, slowing its descent.
After landing in the Utah desert, the capsule was left to cool down for 30 minutes. Then the capsule was inspected carefully to see if any damage has been caused to the capsule. Then the capsule was safely put on a helicopter and transferred to the NASA's Johnson Space Center in Houston, Texas. This sample will be studied for decades to come, providing clues and answers about the formation of the solar system and formation of life on Earth.